We can just get started here. So I'm Patrick Mann. I'm the Director of Operations for WestGrid. Welcome to our, I think it's something like our 10th WestGrid Town Hall over the last couple of years. And they've been actually doing really well. We get good comments about them, and people seem to find them interesting. Attendance goes up and down a bit, but that's only to be expected. So just a few of the admin details to start up on. You can email if you're on the web stream, and video, click the hand item if you want to ask a question, and feel free anytime during the town hall. And yeah, if you could mute yourselves on video when you're not speaking, just make sure there's no feedback and anything else going on. Let's see, outline. Yeah, we've got really pleased to have Robin, the Compute Canada CEO, with us. And then Danny Gruner, the Signit CTO, that's the Niagara Large Parallel System. He'll tell us about that. And then I will work through a few of the usual WestGrid updates, and hopefully that'll take us 45 minutes or so to get through. And we're going to start with Robin. Lindsey, do you want to introduce? You were...
Sure thing. So thanks, Robin, for coming today. This might be the largest audience in terms of geographic diversity that you've had the opportunity to speak to from Compute Canada as you're just starting your term. So Robin joined us in February. A few of us had worked with her previously through her work as the founding executive director for the Leadership Council of Digital Research Infrastructure, so the LCDRI. It was fantastic working with Robin to try and sort through all of the requirements and planning for the ARC space. So quite a few of us have worked with her before, and we see how incredibly capable she is. She also has a lot of previous experience working with policy and government, and most recently was part of the Council of Ontario Universities. So she's, pardon me? Yeah. Definitely familiar with the space, and we're happy to have her on board. So she is on a one-year contract until February of next year, and there's no shortage of things to do between now and then. So with that, I'll pass it over to you, Robin. Thank you.
Great. Thank you, Lindsey. So as Lindsey said, I have been working with digital research infrastructure community for a while. So in a way, it's only really been, I kind of find it hard to believe, it's only been 6 weeks, really, but it feels already like a lifetime, and I think mostly that's because I had already worked in the community, so it didn't feel like I was really starting a new job in the same way as it sometimes does. And as Lindsey mentioned, I worked with the regional CEOs and a few others on the paper that we submitted to the federal government on advanced research computing. And so I guess you could say that I loved working with Lindsey so much and some of the others that I decided to stick it out. And I really did enjoy working with everybody. So it was a big part of the reason that I took this job. So Lindsey asked me to kind of give you a bit of background on me, why I maybe took the job in the first place. I've given you a bit of an aperçu, but I'll maybe give a little bit more detail. And then I thought I would just give you a few of my general reflections that I've had, I guess, from the last 6 weeks. And then I would, I think I'll just update you, Lindsey. I was just pulling up the list again. You asked me to update a little bit on the budget and maybe just give you a little bit of a sense of where the LCDRI work is going. So does that sound okay, Patrick? Is that okay? Great. So just a little bit of background on me. Lindsey's given you some already. But I think I'll just state up front very clearly that I am not a technical person, so all of you have far more skill in this area than I do. I am what in Ottawa would be called a public policy practitioner, a strategic public policy practitioner. So I have spent my whole life basically working in and around government. So what does it mean to be a public policy person? Well, first of all, it often means that we're very purpose-driven individuals. We're here because we believe in the public good. We believe in achieving something on behalf of public and hopefully for the betterment. Usually most of us are motivated by that. The second thing that it means is that we spend time working, our area, our primary audience is government. So, you know, different sectors have different audiences. My primary audience is working with government. But my particular area of specialty has been working with outside groups that are trying to achieve something with government. So I have worked in government and I have worked in politics and I've done various roles, but my particular love and my particular interest is working with groups on the outside, such as the advanced research computing community, to achieve an end with government, so to improve the discussion. And so I end up being a bit of a cultural translator, is what I like to call myself. So I help the outside world understand government, and I help government understand the outside world. So that's my primary interest. And then in that role, what that has often meant is I've worked a lot with complex stakeholder environments, so where you have a lot of different players and a lot of different positions and a lot of complexity in the content to try to help people architect processes that get them to a successful outcome with government. So those are sort of the three skills I would say that I bring to the table. I'm also very relationship-based. So I think that's one of the reasons the board hired me, just to say that the board was really interested. They understood and appreciated that building better relationships between Compute Canada and the membership was really, really important, and it's something that they wanted to put an emphasis on. So again, that sort of plays to the background that I've had. I've worked in a lot of membership organizations, so that was a big part of the reason why I think the board brought me on. Well, I know it's a big part of the reason. So in terms of some reflections that I've sort of noted since I've got here, the first thing I just want to say is I am struck continuously by the commitment of so many people to making advanced research computing work for researchers in this country. And I know that that is sometimes kind of challenging because I work in the same scenario now, so I can see that for our parts of our environment do not set us all up for success and make it sometimes a little more challenging to accomplish what we need to accomplish. Maybe we could streamline things a little bit sometimes, and it can be really hard. So I think the first thing I want to say to everybody is I've worked in a lot of different sectors, and it's rare that I see so much passion and commitment in tough circumstances to make something work. So just, I think, a general shout out to all of you. I'm sort of amazed that our system works at all, and it does, and it works really well for researchers. So I know that that's because of all of you. So I just want to say that up front. I'm just how impressed I am with everybody that I've met. Some of the challenges that I've seen, and these will come as no surprise to any of you, the structure that we work in is a bit challenging. The funding structure is challenging, and the funding also is limited, so or not as high as we would like it to be. So this creates some capacity challenges. We know that we're not keeping up with demand, and we want more demand. That's the point of all of this. We want our researchers using this, but at present, our receptor capacity or our ability to meet that demand, our supply is not where it needs to be. We have a lot of things that we're asked to do on the sides of our desks, like cybersecurity, and there's lots of regulation pieces and other things that come down the pipe at us, and we just don't even have, we don't have funding, so we're all doing more and more with less and less. So I see all of that, and I will be making sure that this is part of the discussion that we're having with government. We've got some challenges with the way that the funding structure works, and making sure that there's an even distribution of funding across the country, and how that works is a challenge. Well, as I've mentioned to you, I know that the governance more generally can be a real challenge. So, that's something else that I'll be working with the regional CEOs to look at. How can we make the national piece, the dialogue there, work better than, and the decision making work better than it maybe has in the past, which hopefully will trickle down and help all of you. So those are sort of some of the challenges, and I guess the big strengths that I've seen. In terms of what's going on politically or at the national level, I have some, I think, good news there. So coming off of the Leadership Council on Digital Research Infrastructure, we were tasked by the federal government. Does everyone know what the Leadership Council is, Lindsey, or should I just give a quick rundown?
This group of audience participants are staff from across the country and also researchers. So I guess you could, I think that the research community might not be as well versed in it as the staff members that are also in attendance.
Okay, so I'll just be very quick. So the Leadership Council on Digital Research Infrastructure started actually about 8 years ago, and it was started by the CIOs, the Chief Information Officers at institutions across the country. They identified that there was going to be a need for a focus on digital research infrastructure, that this was an emerging field and a bunch of emerging technologies that were going to be driving research in a new way, and that researchers were going to be asking for these technologies, and we needed to be ready for it. So they started Leadership Council on Digital Research Infrastructure, and it was and remains largely a coalition of the willing. So it's a really interesting mix. It has representatives of different sizes of institutions. So U15 is there, smaller institutions are there, Concordia, that sort of size of institution is there. And then it also has service providers. So Compute Canada has a seat there, Canary has a seat, Portage has a seat, RDC has a seat. So various service providers from around the country sit there as well. It's currently chaired by Faridun Hamdalapur from Waterloo, the president of Waterloo. And it has been together, as I say, in its current form. Well, it's been around for about 8 years, but in its current form, it's been together for about 5 years. So the federal government asked this group to write 3 papers on the digital research infrastructure ecosystem, and those 3 papers were one on data management, one on advanced research computing, and then they asked us to look at the coordination of the ecosystem as a whole. So we wrote those 3 papers, and the one I wrote, as I say, with Lindsey and her colleagues, and I have to say that it was a lot of work for all of them. They committed a great deal of their time, and I was extremely appreciative of the number of people who, we had a lot of people involved, but particularly those that spent days on end with me writing that document. So those documents went into government. If you think about the digital research infrastructure ecosystem, we ended up with splitting up storage really into, it ended up being that, of course, data management and RAC ended up taking up quite a bit of the storage. Network, Canary looks after the network, so they work with government on that. And then the one outstanding piece, I think, still is the software piece, and we didn't have a remit for it. But in any event, the 3 papers went into government, and we sort of were expecting really a promissory note in this last budget, a note that said that the government was going to look at this and that they would be back to us with funding with hopefully for next year. But alas, we did far better than we thought we would. The government announced $572 million over 5 years for an investment in the ecosystem as a whole. So in all of those elements, not just RAC, it also includes data management, network, storage, and software. So we are now working with government. Government has it's ISED, the department that is responsible for this. So they have started to think through, they're responsible for drafting a national strategy for the digital research infrastructure ecosystem. And they've started their work on that, and the idea is that they will come back to us, I think, in about a month or so, would be my guess. And they'll be working at quite a clip because they need to get the strategy through Cabinet, and then they need to get it through Treasury Board, and then the money will be released, and then they'll be out to us in the usual way, asking us to spend it in a big hurry. So for what is allocated for this year, which is approximately $64 million. So that's where we're at. It's really good news. I think we'll be seeing, as I say, something within the next month or so in terms of their thinking and how they're going to set us up to give feedback to them. Because there'll be 2 pieces to this. There'll be the actual strategy as well as the process around how they're going to manage this. So that's about it. That's what we're looking forward to, and I think it will obviously mean new money for this community. I'm not quite sure how that's going to flow, I think that will be part of the discussion that we'll be needing to have together. So if I answered everything, oh, just one quick, I'm kind of excited about, RAC allocation letters are officially, I believe, going out this morning. They were supposed to go out yesterday, but we had a little twist and things. And so they are, I believe, going out this morning. So I'm personally very excited about that.
Cool. Thanks, Robin. Yeah, that's great. I think that was a great overview. Any questions? I didn't see any come up on the chat or anything. Aaron, anything coming through? Okay. Well, I think, yeah, we're kind of open to questions, so feel free.
Thanks, Robin.
No problem. I was obviously very thorough.
Well, lots of things happening, and I have to say that I mean, it's fantastic news that that the government is adding to our funding, and significantly. I mean, 64 million is this year or next year, whatever, is brilliant. So that is such exciting news.
Now, some of it, again, will be for other parts of the system, but I can't imagine the lion's share won't be for advanced research computing, just because we already represent the lion's share. So.
Yeah,
it looks
exactly.
like there's a question coming in from U of Manitoba, I think. Gregory?
Gregory, you got a question out there, Manitoba? Or somebody there?
They might be muted.
Oh.
Yeah.
Aaron, can you unmute them? Yeah.
I'm looking. Yeah.
As a CEO, so I'm also quite happy to know that there's a funding, from government to support Compute Canada. But I have to say, in general, in terms of supercomputing power, Canadian supercomputing is still quite low if we compare Canadian computing power with other countries. So indeed there's a need for all of us, and especially you, to continue working on soliciting fundings from government. Also, we have to understand that the supercomputer these days is the central core or the central brain for all kinds of R&D. It doesn't matter for that group who got $500 million for environmental research, or somebody do cancer research. Everybody needs computers. So the question to you is that when they submit a proposal, if the proposal has supercomputing power, can Compute Canada be part of the proposal and get part of the funding of that, for example, $500 million? So that would be great to keep enhancing the computing power of Compute Canada. Also for this restructure of this restructure process, we know that the computing node, this is the second question, this computing node from several universities are decommissioned. For example, University of Manitoba, UBC, Vancouver are decommissioned. I'm hoping that, I'm not entirely familiar with this picture. I believe there's a good reason to do so. But I'm just hoping that this is not shrinking, instead this is enhancing the computing power. Yeah, thank you.
Right. So your first question is whether or not the Compute Canada, I mean not Compute Canada per se, but the partners, the Compute Canada and all of its partners would be receiving the funding or be part of the funding on that.
Yeah, my first question is actually we need to, I would encourage my administration team, especially yourself, to solicit funding in a more aggressive manner. Because computing power, supercomputing these days is the central core for almost every type of research. So like somebody do like environmental research, cancer research, pharmaceutical, drug development, and for engineering, mechanical engineering and 3D design. So if there's an opportunity from the federal government for big allocation for several hundred, 500 million, for example, that example, can Compute Canada get a chunk of it? So if we can get part of the funding from all these proposals, that would be a significant amount of money. So can we outreach and reach out to those groups and be part of the proposal? And this is based on the understanding that in general, the supercomputing power of Canada is still way behind lots of other countries. Yeah.
Right. So yes, absolutely. The idea is for advanced research computing to be an integral and important part of any funding that comes forward from the federal government. So that is definitely part of the discussion, and it was, as I mentioned to you, the regional CEOs and through the Leadership Council worked really hard on a proposal that went into government that made that really clear in the proposal. The government has stressed repeatedly to the entire community that it's working with that those LCDRI reports are the basis of the funding, or the reason that the funding was given, and so they will be used as the blueprint for starting to think about how that money will be released. So the really good news is that we had an entire report on advanced research computing, so we know that advanced research computing will definitely be part of the government strategy moving forward. On your second question, consolidation is something that CFI has been pursuing pretty aggressively more recently. I think they've had it as a policy for a while, but they've really been pushing it a little bit more. From a CFI perspective, and it's true, the point that you were making in your first question, there is not really enough money to ensure the supply is not there, and we don't have funding to increase the supply. So they're having to be careful and prioritize the spending that they do have, monies that they do have. And so they've made a decision that the way that they believe that it is most efficient and effective to prioritize that funding is to move toward more consolidated systems, because there's the possibility of achieving economies of scale and other things. So that's why they're moving to consolidated systems, and it really is a reflection on the funding and the requirement to prioritize. But in terms of actual capacity and increasing the capacity and the supply that we have, the new funding announcement from the federal government, I am sure, will provide some injection funds for all of us in the not too distant future.
Robin, there was a question that came in to me by chat through the web stream. Somebody
Yep.
asked, do you have any indication if this money is money that has already been announced or new money?
This is a really good question. There's for sure new money in it. What we don't know, the devil is always in the detail, isn't it? So what we don't know is whether, for instance, Canary has, I think it's approximately $30 million per year. What we don't know is, would that, for instance, the Canary's $30 million, would that be in the, would that be included in the amount that they've already released, or is it because it's already what we call booked money, it's money that Canary already has on its 5-year mandate? It may be that this is actually all brand new funding. We don't know. There would be a few other places where there may be some, you know, some already booked funding, like CFI, for instance. I don't know if the money that they've already got for us is included in that. I don't think so, though, because it would have been money that was already off the books and given to CFI, so I suspect that's not the case, but we don't know for sure. So it's a very, very relevant question. Yeah.
Okay, thanks, Robin. Yeah, I think that's great. Yeah, I guess we can send you emails and things if we've got other questions.
Absolutely, and I'll be working, as always, closely with Lindsey, so, you know, he'll be in the loop when I'm in the loop, so.
Cool. Yep, and we can certainly pass questions on too. So, yeah, thanks a lot for giving us the overview and such.
Okay, the only other thing is if you're talking to anybody from the federal government, the one thing I would appreciate is if you could say how, to the point of the question from University of Manitoba, if you could stress how important it is for the future of research in the country, that advanced research computing is funded, and that it's important, and that you want to say thank you, the money, that it was a real leadership, it showed great leadership on the part of the government to invest in it, and just to say thank you, that would be great.
Sounds good, yeah. Good. Okay. Well, thanks, Robin, and I think we can move on. I'm really pleased to have Danny Gruner here. He's the Signit CTO. Signit's the University of Toronto site, and they've got the Niagara large parallel system. They're just in the final stages of installation, so we thought it'd be great if Danny could come and talk a little bit about it and what it looks like. Danny, I think, are we unmuting you? Yeah, Danny's got. I think Danny's been with Signit for well over 20 years. He's got a chemical physics background, but his expertise is certainly around parallel computing, high-performance computing architectures, programming languages, those kinds of things, and say lots and lots of experience. So over to you, Danny.
All right. Well, Signit's not that old, so I'm old, but Signit's not that old.
Not old.
I've been at the University of Toronto forever, but no, Signit as it stands now was formed about 10 years ago, 11 years ago, something like that. So anyway, I'm glad to be here. I'll just give you a brief, hopefully very brief overview of what Niagara's capabilities are going to be. We're working very feverishly on getting it ready for the onslaught, for general use. In the meantime, we have onboarded a couple of users who are helping us debug the system, stress the system, all those things that are necessary before we can open it to everybody else. So I'm going to share here a little slide deck that I have. Hopefully it'll be visible. Okay, there it goes. And as I say, I will very quickly just go over the salient features of this new system. It's pretty large. I mean, considering the size of systems we have in the country, we have 60,000 cores of Skylake. That is 1,500 nodes at 40 cores apiece. 192 gig of RAM per node, and they're interconnected with EDR InfiniBand. The salient feature here is that it's a new topology for InfiniBand. It's called Dragonfly Plus, which essentially allows us to have a non-blocking architecture. We have about 10 petabytes of disk and a burst buffer, which I'll talk about it briefly a little bit later. That is a solid-state disk that allows us to have very fast and very high IOPS intermediate level of storage. Currently, the machine is rated about 3 petaflops of LIMPAC, so it's almost 5 petaflops, but peak. But it's once you put it through its paces, it's about 3 petaflops. Today, it would be put at around number 42 in the top 500, whatever that means. It's not a, we all know it's not a great measure of things. I was looking at this other benchmark called HPCG, and we would be around number 39 or thereabouts in HPCG, so roughly comparable. The nodes, as I said, they're Skylake processors, 2.4 gigahertz, 192 gig of RAM per node. We run them stateless. There are no disks on the nodes whatsoever. They boot from the network and load their OS into memory. So overall, the total memory per core is just a bit over 4 gigabytes that will be available to codes. The interconnect is interesting. This is the topology that Cray has been using for quite some time, and it enables them to scale out really large. So what this topology does is within what are called the wings of the Dragonfly, there's complete non-blocking architecture. In our case, it's over 16,000 cores in a wing. But then across wings, there's quite a lot of interconnection. And in the latest version of InfiniBand, Mellanox implemented something called adaptive routing, which allows them to route packets in different ways to effectively end up with a non-blocking type of communication. It also has congestion control. So this is really important. This is, again, something that Cray has been doing for quite some time. This time, we did it with Mellanox. Because it doesn't require big, director-type core switches, then the overall cost of the system was reduced. It also means that there's a whole lot of cables, like a hell of a lot of cables in there. Just the cables that connect the compute nodes to the central core, the core, all these made up all these smaller switches. There's about 40 kilometers worth of fiber just in those cables. So it looks like blue spaghetti under the floor, but it's kind of cool. This is a sort of a picture of what would be a typical Dragonfly, where each of these would be the wings, where within the wing everything is interconnected really well, and then there are many connections across wings to all the other wings. Again, I don't expect anybody to understand it. I certainly don't, but some people do, and that's what's important. This is in our case. There's a typo here. These 756 should really say 432, but forget that. It just means is that in each one of our of these three groups that I show here, there are 432 nodes. So multiply that by 60, you end up with over 16,000 cores in each one of these. And this fourth group has 204 nodes, plus it also has all the storage on it. And then there's a bunch of switches. This is just a smaller diagram. Again, this is details. Just the storage that we installed. We're in the final stages of installing the whole storage. We first had only 1/3 of the capacity installed. The other 2/3 came in and are being installed this week. In total, there is going to be about 10 petabytes of available storage. That will include home, project, and scratch. It's all GPFS. It's all central. It's all very high performance. The performance is going to be close to 100 gigabytes per second for this file system, for all these file systems. And as I say, it's running GPFS. That's the IBM parallel file system. It's all provided by Lenovo, but that's they're the makers of the system we bought. We also have this thing called a burst buffer. It's an intermediate tier of storage that is much faster than regular spinning disk. It is serving NVMe over fabric, that is over the InfiniBand fabric, effectively making it look like local disk, like local NVMe drives, solid state disks, except that we have a total of 512 terabytes of disk in a RAID 1 configuration, so that is mirrored for just for security. 256 terabytes of available storage. The bandwidth 160 gigabytes per second, and very high IOPS. I don't know the number, but it's in the millions. So it's really quite significant. This will enable things like fast checkpoints for large codes. It will also enable calculations that are done against databases that require fast access. If they don't fit in RAM, they at least will fit in this type of disk. It's only temporary, and we're still not sure how the workflow management for this storage will happen. But again, it's new, so we're just exploring. Here's a diagram of all the different tiers of storage for the computer. So there's memory, obviously that's the fastest. In between memory and the parallel file system, there's this burst buffer. So you can do checkpoints and restarts within this area. Eventually, whatever you save to the burst buffer has to be copied to the main parallel file system. Depending on the amount of I/O you do, you may be able to directly write on the parallel file system and not be hampered by the bandwidth. So if codes are properly written to do asynchronous I/O in parallel, then that should suffice. And then, of course, we have the HPSS tape archive in the back, where people can store, for longer term, all the data that is not needed on spinning disk. This came from the company that provides the burst buffer. Is just showing that it's all on the InfiniBand fabric. But again, I'm not going to worry about that. For software configuration of the system, it'll be pretty standard. We'll be running CentOS 7, like all the other clusters, all the other new clusters we're running in the country. Authentication will be with a compute camera passwords. We now have the LDAP available on our site, and we are authenticating against it. We will have 2 software stacks. There's the CVMFS distributed software stack that is currently running at CEDAR and Graham and other places. That will be available, but we're also going to have our own specialized software stack. There are a few reasons for that, and I'll talk to that in a sec. Partly it's that this is a different architecture, so we have to make sure that whatever software we provide is properly compiled against Skylake. In addition, because we have this InfiniBand, which brings us a number of capabilities to the system, we have to make sure that we use the proper MPI stacks to take advantage of it. We have found that even benchmarks that were run before the system was purchased. So during the RFP process, we required a number of benchmarks to be run by the vendors. We have found that those benchmarks actually run significantly faster. Not all of them, but the majority of them run significantly faster on the network that we have than on the than whatever the vendors were suggesting was the performance. This can be attributed primarily to the offloading of MPI collectives to the network itself. So InfiniBand is able to do a lot of these operations, all the reduce and global sums and a whole bunch of all-to-all communications. A lot of that computation is offloaded to the network itself. So we have found in some cases 30, upwards of 40% better performance on this network, and even better so if we use an MPI stack. It's an open MPI that has been tuned by Mellanox. So again, these are the kinds of things that are really important, especially for very large jobs. If we compare the new Niagara system to the old GPC that for which we still have a little bit more than half running for maybe another 4 weeks or so. So we deployed that one in 2009. So this is, it's a little long in the tooth. That was 45 racks. The current system's 21 racks, so it's a lot more compact. The old system was 30,000 cores, just over 30,000 cores. The new one is 60,000 cores. So you can see how much more compact it is. We had the first large Nehalem cluster installed. Now we have Skylake. There's just the different generation of Intel CPUs. The number of cores per node was 8. Now it's 40. RAM, you can see we have more than double what we used to have per core. The network is significantly better. The total bandwidth of the network per core has not changed. Right? We still have the same 2 gigabytes per core kind of bandwidth, but that's the way the networks have evolved. Storage went from about 2 petabytes to 10 petabytes plus the burst buffer. The OS It's just newer OS. Total compute capacity is about 10 times the old system, at least in, under certain measures. Maybe not all codes are going to run 10 times as fast, but they run significantly faster. The other thing that's really significant is that it uses about 2/3 of the power. So electrical power. So 10 times more compute power for 2/3 of the electrical power. So that was the main reason to stop running the old system. It's just too expensive to keep it going. We're doing the user migration basically as we speak. We're copying all the home directory, Scratch project, all that stuff. We're copying over to the new system. And at some point, we're going to have a cutoff that says, please, no more running on the old system. We've got to do a last pass and make sure all your files are available. We expect it to be ready for when the new allocations start, which is in about 2 weeks. And this was just a summary of the timeline for the process. We started the process in January, went till September, the whole RFP. We negotiated. We decommissioned the old TCS in October. In November, we decommissioned half of the GPC. The new systems deployed. As I said, we're in testing mode. We've had some calculations run. Some people have been running calculations on upwards of 48,000 cores simultaneously, which is pretty darn large. Nobody else can do it in the country. And we're onboarding a couple more friendly user groups to help us put the system through its paces, debug, and perhaps get some quick science runs in the next week and a half or two. And that's that.
Yeah, thanks, Danny. Yeah, that's great. Yeah.
Questions?
Yeah, I've got a couple minutes for questions. And yeah, I think one question was just, can we have the slides? And I think Erin said that she would try to get the slides off you and put them in our slide deck.
I'll send them to you, sure.
Yeah, perfect. Yeah, because a ton of information there. Yeah, I think this is really, really exciting.
There are a couple of mistakes, but still,
yeah,
give or take.
Yeah. No, I think this is great, and
I see Falk has a question. What's the policy of queuing going to be? We are going to provision by node only, not by core. Preference will be given to large jobs, and yes, we will have relatively short queues. Initially, we're going to do the same thing we used to do on the GPC, which is 48-hour queues. Single length, shorter jobs will run faster. We'll be able to fit in scheduling holes, and then we'll see how that goes. We don't expect to have 28-day queues, not on this system.
Yeah, I've had this discussion with Falk before about very, very short queues, but maybe I'll let you and Falk, you and Danny.
Falk is suggesting 8 hours. So yeah, we've been thinking about it. Maybe it'll be 24. Maybe it will be 12. I know that some of the very large supercomputer centers in the States and elsewhere, they don't do more than 12 hours for maximum workload, and it's something we'll consider. So it depends on how it goes. We'll tune it.
And there was a question there from Manitoba. Could we propose some users for testing?
I already have. we already have quite a number. I'm going to write to Falk just this evening, later after this town hall is done, because we've been back and forth with him. He has some really interesting big calculations. We have some people from the Atlantic. We have some people from elsewhere in Ontario. If you have a proposal from Manitoba for some large calculations that you would like to test, just write to us. Write to me or write to support at Signit, and we'll see how, if and how we can onboard you. We don't have a whole lot of time before the allocation starts, so it's a bit of a race against the clock, and while at the same time trying to get some of these jobs running. So,
if I may, this is Falk, over audio only. If I may just comment on the wall clock time for queues. I mean, we're also running on the NSF Blue Water system in Illinois, and have been running with our collaborators on many large NSF systems as well in the past. And what we always find, and you probably have seen that too, is that the only way to really allow for large jobs is to have short wall clock times, because otherwise this is the fairest way to allocate, and short wall clock times are really critical, especially for clusters that are supposed to run big jobs, because otherwise you will not be able to quickly free up enough of the large domain that you want. And so if the goal is to have also to allow jobs that are a quarter of the machine, which I hope is the goal, then really short wall clock times are key, and I think 8 hours is already the maximum. We are running on Cedar on the 3 hours as much as we can, and so that's, I think, a really important point.
I can't agree with you more. Again, as I say, we'll have to play it by ear, and see how it goes. And yes, we are totally aware that may be the best solution for how we run the system.
But the goal is to have these sort of, I mean, you say 10, 24 cores plus, but I guess the goal is to really allow people who can run on 20, 30,000 cores, allow those jobs as well. Is that the goal?
Absolutely. Yeah, okay. Absolutely. I mean, when you have 60,000 cores, it's hard to schedule 30,000 core jobs, but we will have to do it.
Well, I think if you have a short wall clock time of 8 hours, it takes 8 hours to free up 30,000 cores if you have a high enough priority user, right?
Yeah.
Yeah.
Okay, yeah. So I'm sure that discussion will keep going, but thanks, Danny. That's great for that overview. And I think it's really exciting to have this kind of dedicated, very large parallel machine, which we really haven't had in this sense of a national resource in Canada before. So yeah, this is great. And I think, as Danny mentioned, it is RAC'd for the resource allocation competition, and in theory those start April 4th. And so I'm looking forward. Everybody can start getting on it pretty soon. So thanks, Danny.
All right.
Right. We're
ask the question about getting other users to test. I think you Manitoba had that question.
Yeah, and Danny responded that we could just give him a call and suggest things if we wanted to. Yeah, only a couple of weeks, so it's not too much time, but okay. Yeah. So I've got a few slides. We're pretty much to the end. But what I'll do is just cover some of the parts that I really did want to cover, just some key points. This slide was the national compute systems. I think we've talked all about that. You've seen them. Just the last entry, HPC for Health, is now a funded national site in Canada, and they have an elastic secure cloud. So they've got capabilities for handling confidential health-related data. If anybody's interested in trying to explore a little bit, and you haven't been using HPC for Health before, then give us a call. We can pass you on and talk to you about that. I think you all know about the cloud. Cloud's going strong. Just one point about that was that we had a rather interesting issue back in February, and end of February and March, where in the cloud we used the high availability capability of the virtual network. So there were redundant virtual routers, and they talked to each other, and if one went down, the other one was supposed to start up or take over, and all great, because we understand that the cloud is a bit different. You have users that are on the cloud all the time, and it's hard to go down for even a small amount. But there turned out to be a bug, and so when the high availability failover actually started to happen, the whole thing failed. And that turned out to be a really serious operation to try to figure out how to pull that apart, what was going on, how OpenStack was working on it. So the Victoria guys worked on that really very seriously for quite a time. And here's the usage graph, and you can see that week 09 time when everything went down, and indeed things were really seriously out for a couple of weeks there. What they've had to do is take out all that high availability capability stuff, and the thing is running now without the virtual redundancy, and that seems to be going pretty well right now. And we'll be working with OpenStack to fix that up. And you can see the other outage back in week 3. Week 3, that was in January, and that was the Spectre meltdown bug that everybody patched. I'll just switch briefly to the Cedar GPU usage. This is on Cedar, the SFU machine, and this starts on July 1st when Cedar first came up. And I just note that GPU usage is inefficient at the moment. We're hoping that'll ramp up as users become more used to having 4 of those NVIDIA P100s on a node and figure out how to use them. And for instance, the summer schools that WestGrid is doing in June will have GPU sessions, so one can try to improve this GPU usage and get it up closer to 100%. Wanted briefly, I think we had a question early on about the continuing systems. So parallel GRECs are at UCalgary and Manitoba are being continued as local systems. And you can talk to your local IT services. Jasper and Hungabee are not actually up right now. They were defunded back in the autumn. Oops. But I think U of A is going to try to bring those back up for U of A users. Really nice little extra on this is Orsinus at UBC on the top there. MSI or CFI have agreed to keep funding Orsinus for another year, so that's great. That's 10,000 cores. So we're looking at that as sort of a bonus. Still going to run Orsinus as best effort. So the RAC letters went out today. I think, Robin, you mentioned that. And you'll see, some of you will see an allocation on Orsinus. So it's really good. And very much, I really want to thank UBC, too, who had also agreed to fund it and do their part of the matching funds. So great stuff there. I won't talk about that. I will talk about this one. You got to get your data off all those local machines. If you're a local user and you can work with your IT folks, that's fine, that works. But both the Manitoba for GRECs and Calgary for Parallel guys have agreed to keep the login nodes going for at least one more month, April. And after that, well, we can't keep the data. We have to delete it. So you got another month to get your data off if you haven't done that. I think we've seen that most people have already got their data off. We've sent messages since back in the autumn. So I think everybody's pretty good. So this is a sort of last minute one. Just really check that out and make sure you got it. I think we just got that. I've got all sorts of slides for the fact that the RACs are out. You can look at the details there. The account renewals. Remember, we do this every year because some of the key things there, how many papers are we getting? We present this to government. This is a key when we have to justify all the stuff that Robin was talking about how much good science we're getting out of the whole works. So I think the announcement will come out next week. In fact, the CCDB website is up and running right now, and you'll ask to update the Common Curriculum Vita. We had a real problem with the CCV last year, year before, because the only way to update the CV was that you had to delete the original one that's online and add another one. and that was a real pain because you had to add in all your references. That's fixed up now. There is an update capability, so you should just be able to go in and update the CCV. And I say it's really, really important. We rely on this information for our reporting, for the field-weighted citation index, for all those good things that we work on. So that's coming. And then finally, just to note that WestGrid, we've got our usual training sessions coming up. And there's a few noted there. These are the bi-weekly training webinars where we get interesting people to come and talk about various sort of hour-long topics. Alex Razumov is our training coordinator. He's been working on those ones. And then a number of really interesting ones here. At the end of April, there's a software carpentry Train the Trainer. So I think a lot of folks are taking the software carpentry now. But we're always on the lookout for trainers, and in fact, the general idea is that this should eventually be pushed down to the institutions. So if anybody's interested, certainly get in touch. There's a website, and get in touch with Alex. And then the other thing I'll note too are the 2 summer schools, June 11th to 14th, the third from the bottom, and June 25th to 28th at Manitoba, UBC in Manitoba. So keep an eye on those. We had very, very successful summer schools last year, and we're going to try to keep doing 2 every year, and these are on-site. So it's you know, with WestGrid's quite a distributed with 4 organization with 4 provinces. So this is a bit of an effort, but say they're being successful, and we'll cover things like GPUs and new languages, visualization, those kind of things.
There's a question from U Manitoba about CCVs, I think.
Where was that?
Coming.
Yeah. Patrick, I have a comment on the CCV. Right now, we know that the CCV for Computer Canada is different from NSEC Discovery Grant, which for NSEC Discovery Grant considers only the research activity publication of the past 6 years, which makes sense to me because when it comes to supercomputing, the research is even more updated and the period is shorter. So why should we consider research activity of past 10 years, 20 years? Why not just use the NSEC model, but just considering the research activity of past 6 years?
Good idea. I will. I'm leading the RAC admin team, and we're doing a retrospective. So I will bring it up there and see what we can think of. Yeah, I think it's a good point. Thanks. Yeah, and then any other questions? We're good. And then finally, we have a user training archive, and that's where all these training slides and the materials are going to be put. It's sitting on GitHub, so you can download it and play with it, all that kind of stuff. So feel free to have a look at that. And I think...
One question that's come in from email. It's quite long.
Can you read it off?
Maybe we can answer it offline. It's
okay.
Quite long.
Detailed question? Sure, I can do that. Yeah. Okay, I think that's it. And say many thanks to Robin and Danny for coming in. I think we've covered kind of the high level and then the immediate details of things like Dragonfly Plus. So good coverage here. So thanks, everybody. Great.
Thanks for having us. And Danny, I appreciated hearing your presentation as well. Good to meet everyone.